Well, hi, good morning. Thank you for coming and joining me in my shop, spending some of your time with me while I work on this radio. Today is August 14th, and what am I going to do next? That's the first question. What to do next about this radio? So, am I inclined to change all those capacitors that are in there? I'm not inclined to change them all, though that may be what happens in the end. I just as soon leave whatever I could in there once the radio's operating properly. But I'm going to do them in some kind of rational order. I think what we need to do is study the schematic a little bit and see if we can't pick a couple of hot dogs to go after. Hot dogs, eh? Okay, let's take a look here. So just before I get going, I'm going to make a lot of statements while I'm looking at this. Some of them may not be true. I only know so much. I know stuff. I don't know everything, so it's easy for me to say something that may not be true. Plus, out of my mouth comes the wrong words at times. You've probably noticed this with people doing things live on TV. Maybe watch a newscaster, and you kind of know, ooh, he said the wrong word, and he appears to be completely unaware that he said the wrong word. Well, that happens to me too. So you just need to be a little bit aware while I go through this. So why don't I'll just comment on the capacitors that are in here as best I can, and some of these I really can't. Look at these ones. Look at how small that is. It's a teeny guy. There's a small guy. Another small guy. Here's another small guy. What do they have in common? Well, they're all associated with the front end operation of the radio. Even this one down here, it's not really part of the front end, it's part of the local oscillator coils here. But it is connected to the first two. So I think that's kind of interesting. Look, there's a little guy over here. But these are all small guys. These are probably all mica capacitors and probably all in good shape. Probably. So there's really no need to pay too much attention to these, at least not at this point, not without some reasoning as to why. Why are they so small when so many others are so big? Well, I don't know the answer to that question exactly. Could be the impedances in this circuitry is very, very high, so you just need small capacitance to do the job. It could be something like that. I don't know offhand. Okay, let's go and look at the... You know what, let's do this. Let's find the capacitor that's responsible for controlling the automatic volume in the radio. Not so much controlling it as damping the variations in the voltage that's applied to the tubes to cause the automatic volume operation. Well, one of the reasons for this, I won't go into it because I think I'm wrong. Somebody can say, look, there's another small one up here. Okay, so the way to find those capacitors, or that capacitor that's doing the AVC damping, I mean that's the right word for it, you start by looking for the diodes here in the detector tube. Here they are. And you look for the output coming from the secondary side here. Here it is. And you see, oh, some of the output is heading back through the audio circuits and out the speaker, but there's another wire going this way. What is going on here? So these two diodes here, sometimes they only use the one, but in this case they've got both of them going, will rectify the output of this transformer. It's a RF output, 455 kilohertz probably in this radio, and it rectifies it, and so what you get is a buildup of DC, or you get a DC result, a direct current result, and that's on this wire. Now the direct current faces a big resistor here, so not much current going to flow this way, and this way it hits a capacitor, so not much going that way. This way it hits a huge resistor. This is interesting. Look at the size of that, 2.2 megohms, a big guy. So if we keep going, come along, oh, a 0.05 capacitor. That's maybe the AVC damping capacitor. we could be pretty sure if this side went to the B minus line. Where does it go? It goes over here. It's all involved the antenna here. Let's just follow this very carefully. So I'm following. So no DC can get past here, Jim. So I was tracing it as if some DC were going this way, but it can't because of this. Okay, so the DC that's built up here, some of which is getting across this resistor, charging up this side. Well, maybe it goes up this way. If we go up this way, another capacitor. This one's hooked up to the B minus. This is the B minus. On this schematic, they've shown the B minus just wrapping around the outside of the radio, outside of the schematic rather. So that's caused this capacitor to be pictured way up here. Often this capacitor is sitting somewhere here on a schematic, and that's why this guy fooled me a little bit. Let's keep going up this way. So DC can't get through, but a DC voltage can drive charge through this, another large resistor here. And now you've got charge on this side, can't go through this capacitor, and meets a grid here, which is a dead end. So no current flow, no current flow, no current flow through here. So what that means is if the voltage here is 1 volt, it's immediately 1 volt here. There's no voltage drop in here because there's no current flow. Okay. Now it also is connected here. Why don't we go through the winding? DC can go through this winding, come down here, and it makes it up to another grid. So the voltage that's developed here, which is found here, get across this resistor. Well, it doesn't have to kind of get across because there's no current flow in this leg, in this line at all. So any voltage here is going to virtually immediately show up over here. Any DC voltage is they're going to track fairly equally, except for this capacitor. So this capacitor is like adding a bucket, a charge bucket. So as some charge comes through here, and normally the voltage here would match this because there's no current flow here. Instead, some of that is going to go into the capacitor, and as the capacitor builds up charge, the voltage on this side will go up. So there kind of is a current flow right in here. A current flow, a charging current for this capacitor. Could happen fairly quick, but then again, look, this is a big resistor here. So the amount of charge I can get through it is reduced or limited by the resistor, or slowed. You could even think of it that way. So this guy doesn't fill up very fast. He also doesn't empty out very fast. When it goes to empty out, where's it going to go? Well, let's say the voltage here got to be 5 volts. And then the signal goes away over here, so the voltage on this side drops to 1 volt. And you got 5 volts and 1 volt. Now this capacitor wants to discharge through this resistor, but again, it's a great big resistor, so it's a slow poke. So that means the voltage over here is kind of steadied, or it's an integrated voltage of this variation. So let's say you're tuning, I better not say that. Let's say the signal you've tuned in, I better not even say that. I won't say anything. Let's just say whether it's a strong radio you're listening to, radio signal, or a weak radio signal, the effect of this circuit is that it'll come out the same volume. Oh, wait a minute, how does it do that? Well, this voltage is applied to these grids. And these tubes are constructed, manufactured specifically to have a characteristic where as you vary the bias on the grid, you also vary the amplification factor through the tube. I think the proper word is mu for it. So the way it works, the way they've designed this and made it work, is the more negative you make the grid, the less the gain on this tube. And this one too. This one also is hooked up grid is hooked up to this voltage. So you have a slowly varying voltage in here, if it varies at all, as compared to the voltage that might be out here. Now, once you tune the station in and you're just sitting and listening to the radio, voltage here will be steady and the voltage here will be steady and pretty much equal. And the charge will just sit here not doing anything. And that'll be it. Now, negative voltage, how come negative? Well, it's just because of the direction of the diodes here. I mean, they've been chosen on purpose to be, this has been wired on purpose to produce a negative voltage. There's a huge advantage in this because it's hard to get a negative voltage in these radios. Where would you get one from? All you have is a positive power supply. So you have some degree of positive voltage available, but no negative voltage. Now, there are some tricks, some bigger, more complicated radios use to generate a negative voltage. But one trick a lot of these radios use is they rely on this. They rely on the detector to generate a negative voltage that can be applied to these grids. Oh, I've talked a lot about that. So this guy, because he's hooked up to the B minus, must be the damping capacitor on the AVC system. This guy, I'm not quite sure what he's doing. He's allowing AC to go through here. So for instance, an RF signal would find it easy to get through here. And if you look, it's through a big capacitor, and you find B minus. Whoops. So this might be a way of bringing B minus into the picture, or the radio's return or neutral, if I can call it that, into the picture out here. But you say, wait a minute, there is a ground out here. Look, there's a ground right there. So that's a connection back to the chassis. But if you follow this wire back, other than touching the chassis, it doesn't go into the radio at all. This is a outdoor antenna. I believe this is what they're trying to model here. It's a long wire outdoor antenna for shortwave purposes. So there's no ground. Oops, sorry. There's no earth ground and no easy return to B minus except through here. So I think that's what this really is. It's a 2 capacitor path to B minus for this part of the circuitry. Okay. Now if this guy were leaky, well, that could be very, very critical. There isn't a lot of charge, or let's say this, a small amount of charge making a big difference in this circuit here. So if this guy's leaking away the charge when it's not supposed to be, then the amount of voltage being built up in here, the negative voltage, is going to be reduced because it's leaking away through this capacitor. And you get a reduced AVC action. In the worst case, and I won't finish that sentence either. I was going to say something about motorboating. So I think both this one and this one, let's say if this one's leaky, what would happen? So what's it leaking to? Let's say it's leaking from here to here. Where's it going to leak to? It's going to leak, well, another capacitor there. No. Okay, we can go down this way. Way down here. It's not going anywhere. And even if this switch doesn't matter where the switch is selecting which coil is active. So we're going through this little tiny capacitor and a 22K resistor. Yeah, I can't interpret this 100%. I think the next capacitor we should go after should be this one. And we'll see what the impact is. Now I've got to find this somehow. I'm going to find this. It's got a 1 meg resistor kind of attached to it. It's attached to a terminal on this IF can. It's attached to this, well, we'd find a 2.2 meg ohm resistor and a 1 meg ohm resistor tied together with a capacitor coming out. That would be it. It's also tied directly to this one. The two of them are together on this. So schematic makes it look a certain way, but in the radio it can look entirely different. My best bet is to look for the 1 meg, 2.2 meg situation, and look for this on the first IF transformer. Look for these two resistors on the first IF transformer, and I should find this capacitor. Okay, I'm going. Okay, let's see if we can find that capacitor. So start by figuring out which IF can is number 1 and which is number 2. And we can guess. That's number 1, that's number 2. Well, these are different physical sizes. The number 1 is much bigger. Okay, not that that really matters. So if that's number 2, number 2 is right under here. somewhere under there. Now we're looking for 2 resistors, 2.2 megohm, and I see it already. I see it. It's going to be a small wattage resistor because these circuits are using no power. So right away I see one right here. That's red, red, green. So that would be 2.2 megohms. And it's coming here. It's coming here. It's coming here to this busy terminal with lots of stuff on it. Can we find the other resistor? Can we find it in there? Well, it could be in quite a different location on the end of a wire. So, but this terminal is what is this? Is this what is this? Is this a I can't really tell if it's a. I think it's a terminal coming up from the IF, but really it doesn't look right. It's too big. It's all by itself, sticking way up here. So what else could this be? There's a terminal strip right there. There's the other terminal not being used. So this is probably the riveted terminal. Yeah, I think I see the rivet down there. This is the unriveted. So they put this in the radio for no good reason other than to have a rivet to hold this terminal. This terminal's got this resistor. Let's go the other way. If we go the other way, find a capacitor. Another terminal strip down here. It looks like only one capacitor, but we're looking for a connection with 2. Come this way. This guy's connection's going over here. This isn't working out. This is not working out. I can't find the second resistor. Oh, it was a 1 megohm, wasn't it? So 1 would be, what would 1 be? Brown, black, green. Another resistor with a green third band. Well, there it is, right there. Well, there's a resistor with a green third band, but what's it doing way over here? And it looks like yellow, brown. That's weird. Yellow, brown, green. 4D1, 4.1 megohms. There's such a resistor in that radio. 4.1. There was a great big one, wasn't there? Little tiny one. Little tiny big one. Okay, this is not working out. Follow this wire. I think it's this one. It's so easy to be fooled. Yeah, I think this wire is this one. So we're coming up to the volume control. There's nothing else connected to it, so there's no resistor going that way. You have this small capacitor right here. I don't remember a small capacitor, but what I remember is probably immaterial. How many 2.2 ohm resistors are there in that radio? Well, there can't be many. There can only be one, really. Let's take a look at the schematic again. Hopefully this will clear my head. So there's the 2.2 I believe I'm looking at. Is there another 2.2 in here? There's a 4.7. 4.7. And what was that other one I saw? It was yellow, brown. Okay, what's a 7? I don't know what a 7 is offhand. And my little resistor check sheet is missing at the moment. Where are, here you are. What's a 7? A 7 is purple. A 7 is purple. Purple, purple, purple. That's right. Purple. So maybe the purple has turned kind of brownish there. Because I've never heard of a 4.1, but 4.7 is a standard number. So that's probably what that is, and that's far away from here. See, on one side of this 2.2, there should be 2.05 capacitors coming off of it. But, you know, one of them could be located at the end of a wire somewhere else in the radio. The other end goes to the volume control. We saw that, didn't we? Isn't that what I saw? I'm looking in the radio. I've lost sight of the resistor. There it is. No. Yes, it does. Via a wire. Via a wire. It goes there. Via a wire. Yeah, to the volume control. Right. Didn't I drink enough coffee here? I think I did. So, okay, so we know this end. Did I win something? What did I win? It's just my coffee break indicator. It's 9:45 in the morning. Okay, so we can identify this end. So we know these capacitors got to be found off of this end of that 2 point, and this resistor should be found somewhere too. Oh my gosh, everything's dinging and ringing around me. Let me stop for a moment. I have to check my telephone, drink some coffee. Okay, it was a text from the grocery store. You can pick up your groceries at. Yeah, we order our grocery store groceries over the internet and go pick them up. We don't go in the store. It saves a lot of time and let somebody else wander around that store. Here we are. Here's the end that goes to here. Here's the other end that goes to this terminal. Right away we can see one capacitor right here. Now there's another capacitor here, but it's hooked up to a different terminal. There's one right here, and it's also hooked up to the same different terminal. But if you look close and using X-ray vision, right down in here is another capacitor underneath. You can just see some of the yellow I'm poking at. And look really close. The wire lead from this lower capacitor goes right to there. So there it is. So we got him. We got him. This guy and this guy. Now which is which? This one's coming over to connecting to a trimmer capacitor. And the other one is connecting to a tube pin. Let's go look at the capacitor or a tube pin. Who's who? Did I say a capacitor or a tube pin? A tube pin or... yeah, a capacitor, a trimmer capacitor. So this one, does this one connect to a trimmer capacitor? No, it connects to a resistor. Now it goes on this line. Could this line be connected? Oh, this line could be connected to trimmer capacitors for sure. And I may have even missed them. Well, here's one. No. The line stops here. Okay. What about this one? Is this guy connected in some way to a trimmer? Wait a minute. That's the tuning capacitor. That's a trimmer right there. So the guy hooked up to the trimmer capacitor is this one. The other one must be the other one. So this would be the one, and we got to find this 1 meg resistor, sort of for confirmation purposes. We don't have to find it, but I'm pretty sure I know which is which now. So, okay, back to the radio. Okay. Trimmers, this has something to do with the local oscillator. The AVC one is down under here. a situation like this, I'd be inclined to go, well, we're going to do all these because they're all jumbled in here. Might as well do them all. But then you don't know the effect of anything you've done, and if something goes wrong, if you've done 4 capacitors. So the other side of this one is connected also to the same terminal as this. Now once in a while you'd be fooled in these radios, and the terminal on the tube socket is actually unused by the tube. It's a freely available terminal, and the radio designers use it as nothing more than a connection point. But I'm not sure that's really the case. So we'll look at the schematic again. Does the other side of this AVC capacitor connect directly to one of the pins, and on that pin, on that tube, is another capacitor. Okay, so does it connect directly to a tube pin? I have to look at this very carefully. Resistor, capacitor. The answer is no. What about this one? The answer is also no. Oh. This one does. Have I got the wrong capacitor? This one hooks right to a tube pin. So what I've done is I found this resistor. I figured out which end is this. The other end, I found 2 capacitors connected. One of them is connected to trimmers. There's a trimmer. The other one, I made an assumption at that point, didn't I? That the other one I've seen must be this one. Never found the 1 meg. Okay, let's go back, look at the radio again. How complicated can this be? But this is how I make mistakes anyway, as I finally reach a point, I think I know what I'm doing, and without enough evidence, there's no doubt this capacitor, this one here, is hooked up to this terminal. Now, there's supposed to be, wait a minute, there's another wire here. It's going way under all this stuff. And what you want to bet that resistor I'm looking for is right here. I can see green. When I look down here, I can see green. So there it is. So there's the other resistor. So that's just verifying this terminal, this capacitor, and so we're left with this one going over to. Oh, didn't I say something about you get fooled because the terminal, because it doesn't actually, the terminal's not used for this tube. Is that possible? You really don't want to make a mistake working on these radios. So for some reason I pulled this out. Oh, yes, I pulled it out. It's 12SK7. 12SK7. Okay, Mr. 12SK7. Let's dial them up here. 12SK7. There's the outline there. Now, what pin are we talking about here? We are talking about pin number pin number 5, I believe. 5, 4, 3, 2, 1. No, maybe not. 1, 2, 3, 4. Yeah. Pin number 5. What is pin number 5? So we take a look here. Let me see. So 5 is a cathode. Five is a cathode. Cathodes are grounded in this radio, are they not? Quick, let's look again. 12SK7, what's going on with the cathode? 12SK7, what's going on with the cathode? Cathode is right to the B minus. And look, there he is. So they've connected this line to the terminal on this tube right here on the cathode terminal. Found the 1 meg. That's our guy. So we're gonna pull this guy out and change him. Okay. Pull him out. I've anesthetized the radio first by pulling the plug out of the outlet, so it can't feel the pain. Wow, that's a little easier on this end. Take it right off the terminal here. And I'm going to put a clip lead on there because you never know where to come from. I'm already losing track of it. Okay. Now maybe if I pull on it, better. Not much better. Better access to that terminal. Okay, I'm going to leave some wire here. What did he cut just now? What did he cut? He cut the right thing. I'm sure if you're doing this kind of work, you occasionally cut a wire, and when you go to pull the part out, it's still soldered in because you've cut the wrong wire. 0.05, all adding up. What condition is this guy in? How much you want to bet? He's in pretty good shape. Let's see. Let's see. Looks good. Okay. What's going to happen? 50 volt setting. If you can read the numbers there, it says 25, but if you measure it, it's actually 50 volts on this setting. Here we go. Popped right open. Just fantastic. 150. She's a beauty. What's the rating? Is 400. Keep going. Oh, you know what? This is starting to look like a bad capacitor because it should take time to charge, so this should close briefly. You know, 0.05 at this kind of voltage, we can go higher. There we go. Oh! What happened there? We've blown the capacitor up. That's what happened. So in case you didn't quite follow what happened there, now it's possible the lead wasn't connected properly. Maybe I should have checked that before I went all the way up to that super high voltage. And then the high voltage jumped the bad connection and made it good. So let's try again. 50 volts. Right open. 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 Okay, 350. It's shorting out. Now it's shorted. I've never had a capacitor do this. 50. And then wiggle the wires here a little bit. Huh. Is it a bad clip lead? What is happening here? Okay, we need a test capacitor. I happen to have one handy here. This is not an old capacitor. It's old. It's NOS in good shape. I think it's in good shape. Let's just repeat the test on this. This is a 600 volt capacitor, so I shouldn't worry. Now, did you see that it went a little slow on the opening? See, it's slow. Now we're at 250. See, there's time involved while it charges. 350. Right open. That's a beauty. Watch out now. This got 350 volts on it. No, actually, this device puts a short on the item you're testing when you let go of this control. So after just a moment, not an instant, it takes a moment to discharge one of these. Not an instant. So what's the story on this guy? let's give them another run. This is the strangest capacitor I've ever tested. Okay, I'm sure the connections are good here. 50 volts. You look great. You look too good. See, like it's just too fast. That suggests the capacitor lead itself is broken away inside. And then when we get up to this voltage, it jumps, welds the lead back in. Not a bad capacitor. Or it's really shorted right out. I think it's shorted right out inside. But then when I wiggle it, it's good again. So I think, that's an interesting. This is quite interesting. Never had a test go this way with a capacitor. This is the first one I've certainly tested capacitors where I thought the lead was disconnected inside because it shows an instant response even at high voltages. Okay. Thank you very much, Mr. Tester. Okay. I'm going to put a new capacitor in there and we'll test the radio and see. Now, who knows what condition the capacitor was in when it was in the radio? Perfectly fine? No. Broken lead, no capacitance, no bucket for the AVC charge to be integrated within. That's my hand showing integration. Okay, let's stick in a capacitor. Okay, got the new capacitor installed. Let me just shut off that soldering iron here. And we should test the radio for sure. Let's bring it down. Okay. Yeah, just leave that there. Let's plug it in. Volume is up just a bit. Power switch is on. Watching those dim bulbs now. Good. Normal behavior. That's a good sign. Now, what can we expect here in terms of a difference in operation? Pretty hard to detect a difference here, I think. Let's see what happens. Lots of volume now. Okay, that's the one station. French station. It's at 860. No hint of it. Sometimes I think I hear voices when I'm doing this. So. Okay, one station still. And that buzzing, that's radio interference. I think we can prove it too. There's no hum in this radio at all. It's silent. Okay, that's shortwave. Let's go to the station that I've been listening to, 590. And there you see the interference there. Apple CarPlay. We'll have you ready to go. Okay, so that's it for today. Just that one capacitor. Certainly didn't injure the radio at all. It's still working pretty much the same as it was. The benefit of changing that, there may be a benefit, but it's not easy to notice or detect unless that original capacitor was a real write-off, which maybe it was, or maybe it was going to be a write-off, and I kind of brought it to its final demise when I was testing it. Okay, well, thanks a lot for watching. Tomorrow we'll pick on another capacitor, 2 or 3, however many we can get to, and continue to try to boost the performance. I expect this radio to be able to pick up 4 or 5 stations here in my shop on my bench, not just one. Thanks a lot for watching, and I'll see you later. Bye.